I think we are familiar with GraphQL being at the front runner for the UI layer, like where people talk about different ways to leverage GraphQL for solving the UI problems. We at Netflix took a different approach and tried to bring GraphQL and our data pipelines together to unlock a bunch of use cases that I'm going to talk about. I'm a senior software engineer at Netflix. I've been working there since 2018. And I'm part of the middleware infrastructure team. We are kind of like a central local infra team for our Netflix content and studio engineering, which is kind of like the teams that powers Netflix content building, where we also deal with a lot of metadata like movie subtitles, movie metadata itself, or locations, and so and so. Yeah, we are working at the intersections of workflows. Netflix Connector, which is also one of the popular open source projects, is owned by our team, data, and recently ontologies to empower Netflix. So let's get started. I know there is a lot here, but so to put it simply into three different components, I want to talk about the GraphQL federation layer itself, where each separate teams, like within Netflix or in general, have their own subgraph and kind of put it together to build this overall GraphQL federation layer. I'm sorry, I'm trying to get this pointed. So yeah, anyways. And then we have the data pipelines. It could be the run-of-the-mill Kafka pipelines or like whatever it is with a Flink processor or something like that. And then we have the whole bunch of the ecosystem of data syncs. It can be anything all the way from Elasticsearch to columnar databases to building caches and so and so. And I also want to touch upon the CDC part of it, like where I'll explain or get more into the details of what CDC is, but where we are capturing or reading the database bin logs and kind of capturing their context and then enriching it with the GraphQL processor. So let's get started with a very simple example. Let's review what federation is if you're not familiar with it. Here I'm using a very simple example of movie and reviews. But again, this is not how we do it, but it's a very contrived example. And let's assume that movie subgraph and review subgraph is two different domains owned by two different teams with no overlap whatsoever. But movie subgraph provides, say, a bunch of fields like movie ID, title, and release year, and so, whereas the review subgraph provides reviews for the same movie ID. So it's like two different teams coming together to provide the same entity that is shared across. Let's also continue with the same example and thinking that both of these subgraphs are backed by MySQL databases and simple tables. Very simple movie IDs and title and so on one table and other information and rating on the other stuff. So what is CDC? Again, if you're not familiar, it's short for Change Data Capture. It allows to capture, for example, if you are using MySQL, the database bin log and reflect the state as is, for example, using data pipelines or streams. So that way, we can take the database state and reflect the state as is in some other system and kind of do a whole bunch of other use cases like data synchronization, replication, ETLs, and so and so. Debezium is one of the popular open source projects that provides and supports CDC. We have our own dblog implementation, and there is also Kafka Connect and a bunch of other implementations. So I know there is a lot of talk about CDC, but I want to keep it here because not many people actually directly work with the data that is coming out of CDC bin logs. I don't usually work with day-to-day because we have it abstracted and it's many levels down deep. So there isn't much here. Like if you look at the overall payload, for example, in the first image that is coming out of the movies database, there is the schema itself and then the payload, which has the changes that it's talking about. It says, for example, OP short for operation is C short for create here. And we are saying, hey, this particular movie ID is added to our database, and this is the event that got generated. And so it also says a bunch of other information like, this is coming from this movies database and the movies table and the timestamps and so on. So it's pretty simple actually, but then has a lot of other details and that we don't need. The same thing for the reviews database, like the payload itself and everything the metadata is pretty simple. So this is great, by the way. It has been working great for us, and we are using it leverage. We are using it in a bunch of different ways, like sometimes even taking the CDC data and putting it directly to our Hive tables as is, without any enrichment. But some of us got together and thought, like, what if we enrich the data before it actually goes to the sink? Like, what if we remove the tight coupling? Like, wherein, if you notice that, and if you go back and see, the payload here is tightly coupled with the database schema here. Like, if, for example, you have to change the release year here, that will be reflected in this payload, and you have to update all of your data pipelines downstream. So how do we do that? So that's where we consider having this pipeline of CDC and GraphQL Federation together. So what does that mean? So in here, the CDC payload, like I said, doesn't care about what's in the data or the table schema or like all of the information, but GraphQL does. Like when we say GraphQL Federation, you're not just defining your API, you are also defining all your data, all your business context, and what it means. Like, for example, one team can say, hey, I have this piece of movie information, so this is my movie type that I'm going to establish. And some other team, like productions, reviews, movies, and at Netflix, like movies is kind of like centerpiece of all of other systems, like talent, production, and so and so. And all of them kind of use that as a source of truth and add their own data on top of that. Like connecting, hey, this movie ID 123 connects to this production, connects to this talent, and so and so, and use that as a source of truth. So we have all of this information encoded in GraphQL Federation, and we thought if we can enrich that outside context with this inside information in CDC using a Flink processor. Again, if you're not familiar, a Flink processor is you can think of it as a function on streams, like you can take input as a stream of data, enrich with any inside or outside context, and then output another data. So basically what's happening here is we're taking the CDC payload as is, enriching it with a query to a GraphQL Federation layer, and use that response to do something like that. So let's see how the query would look like from this image. So from the previous example, we are saying, with this movie ID metadata, if I want all of this information together in one place, now I would be able to do that. And this movie ID can be coming from both the movies database or the reviews database, because it's the same in both the places. And Federation layer will take care of calling different subgraphs and getting all of this data together. And this is how the data would look like. Like earlier in the CDC, we only have part of the data, but now we have the entire view together. This is super helpful for us because we have using it in our UI layer directly in terms of supporting search suggestions or search results or a bunch of other use cases, even putting all of the information from multiple subgraphs in one place in the UI. And doesn't have to be federated. So that's when we took it like a little bit further. Like, because federation is awesome, but at the same time, there are certain pitfalls that I will talk about later. But without that, without even considering federation, if you want to take the exact movie entity owned by movie subgraph or the exact production entity owned by production subgraph, and we want to reflect that state as is, as a data product, we can still be able to do that with the movie entity and with the CDC and the data pipelines. And this is powerful because it allows us to build data products with the exact amount of data our use cases need. Like, for example, for an operational reporting use case, they want a segment of the data that is exactly required for their needs, but not the entire data on the movie itself. Because the movie itself kind of has like hundreds of fields that is usually an overkill. And we were able to do that directly, but we were able to do that by skipping the federation and going directly to the subgraph and getting the data in the format like this. So our team wrote a detailed blog outlining one of the use cases that we have built. And this particular use case is called Studio Search, which makes the part of our content engineering graph federated and searchable. So, and another good part of this is that this is all configuration driven, where a user would come to us and say this is the exact part of the query, and this is my configuration, and do everything for me and get me a search index. So what we do is like take that configuration and generate and capture that as an intent and generate a data pipeline, indices and everything automatically, which can also be versioned and incremented automatically, so that the users would get the exact data in the things, like in Elasticsearch for this use case. Similarly, we have built another product that moves the data to any other ecosystem. We started with search, but then we thought, we realized the powers of that, and we were immediately onboarding a lot more users and use cases with that search approach. And we thought we can actually extend it to many other use cases like operational reporting or building caches and so and so. So this is one other data block that talks in depth about what we were doing there. So yeah, ever since we have done that, we are building a lot of other stuff using this pattern, like we are building caches or columnar data stores to build our analytics applications, analytics dashboards, or we are just simply creating views in our Hive tables. And then some of you might be familiar with the concept of data products. It is popularized with the data mesh, the data mesh blog and the ecosystem like a couple of years ago. So we try to use this model to create these data products that are searchable, discoverable, and so and so. So with this approach, we take part of the graph, build a data product, and put it as a searchable product in our ecosystem so that anyone can build another data products on top of that. So yeah, that being said, I want to talk about some of the consideration to keep in mind if you want to implement this approach. Like first things first, we have built a lot of abstractions to not let users accidentally abuse the system. Again, there are several ways users can take advantage of the system by building, by touching multiple points of the data that they don't need, or going across the federated DGS. Like in one case, we have seen a scenario where a user kind of wrote a query that touches up to 10 or more different DGSs, which is quite expensive when we are talking about CDC. So we have made sure to define certain practices like, hey, move only the data that you own, or move only the data that you need, and exactly define what you are moving, where you are moving, by being documented that as part of your config. And run your data hygiene checks periodically, consider leveraging discovery and lineage tooling that we provide to make sure that you're not going over the board. So yeah, this has been a work of our team for many years now, for many engineers and many iterations. And right now, I think this is like kind of like very super successful overall in terms of the number of use cases onboarded in very short time. So yeah, I think that brings us to the end of the talk. If you have any questions, feel free to stop by.